Welcome geometry students to the review sheet help video. Hopefully you've done the review sheet and you're just checking your answers or getting help on the ones that you've missed. I feel like that's the best way to use these videos. However, if you are doing the review sheet as I do it with you, that's fine also, as long as you're learning the math and you understand it and you're ready for your upcoming test. I'm getting my book ready now as I'm talking to you. I'm turning over to page 97. So please go ahead and get your books open, get your homework out or your review sheet out, whatever you want to call it. Get your calculators out, your pencils, all the stuff that you need, your notes, and let's have a great time. Let's start off with numbers 22 through 26. Numbers 22 through 26. Okay, match the statement, we're on page 97, match the statement with the property that it illustrates. All right, now let's take a look at number 22. The measure of angle 2 equals the measure of angle 3. And then we swap it. The measure of angle 3 equals the measure of angle 2. Now, whenever we do that, 2 equals 3 and 3 equals 2, we call that the symmetric property of equality. Now, why equality? Because there's an equal sign right there. So we call that the symmetric property of equality. Now, number 23, the measure of angle S equals 45. Then the measure of S plus 35 equals 80. Now watch what they did there. Watch this. They had angle S equals 45. Then they added 35 to both sides. So now they have angle S plus 35, and they added 35 to this side, and that's where the 180 came from. So do you see what they did? They added 35 to both sides. So we call that the addition property of equality because we added the same thing to both sides. And so that would be letter A. All right, let's take a look now at number 24. If AE equals EG and EG equals JK, then AE, here's AE, equals JK. We call that symmetric, guys. That's letter, or transitive. That's the transitive property of equality, letter B. Now let's take a look at number 25. If the measure of angle K equals 9, then 3 times the measure of angle K equals 27. So they took one side, they multiplied it by 3. They took the other side, they multiplied it by 3. So they multiplied both sides by 3. That's called the multiplication or multiplicative property of equality, letter C. And then of course the only letter left so far is D. And let's take a look at what D would be here if I can get this eraser to work. If AB equals 12, then 2 times AB plus 3 equals 2 times 12 plus 3. Now, I'm trying to see how they did this here. Mr. Earhart's actually at a loss of words here. This is a pretty interesting example. Yeah, I'm not a huge fan of what they did here. Okay, I definitely won't give you one like that. My phone's ringing. Let me pause the video real quick here. Okay, I'm back. Sorry about that. Little phone call coming in. Okay, here's the deal, guys. I know my math pretty well. I've taught for years. I'm not really thrilled with this example they're using, so I would do something like this. Here's how I'm going to give you a problem. I'm going to say something like this. I'm going to say if AB equals 12 and I don't know 2 times AB equals 24, something like that, then, and then look what I'm going to do. I'm going to substitute. See how AB equals 12? I'm going to substitute 12 right here for AB. I would say then 2 times 12 equals 24. Something like that, where you can actually see I start with an equality, then an expression with an equality sign, and then I go ahead and make that substitution. So, okay, moving on. So those are the properties we have reviewed. We had a quiz over those, and we studied those from chapter number 2. Let's continue on. All right, let's take a look at numbers. Actually, let me turn over to the right page. We're looking now at page 160, so you might want to turn over there with me. Page 160. All right, numbers 7 through 10. 7 through 10. I'm going to read the directions out loud. In the diagram at the right, think of each segment as part of a line. Fill in the blank with parallel, perpendicular, or skew. Parallel, perpendicular, or skew. Now remember, parallel lines have to lie in the same plane, and they never intersect. Perpendicular lines, of course, form a right angle. Skew lines never intersect, and they cannot lie in the same plane. So here we go. According to the problem here, it looks like we're going to start off with FJ. Here's FJ. I've highlighted it for you. And GH. There we go. Well, students, look. To me, it's pretty obvious those two lines are parallel, and here's why. I'm going to take blue and highlight the plane. Here's the plane that they lie in. It's that top rectangular square. There's the plane. It's a flat surface. So these two red lines do lie in the same plane, and they will not intersect. So those two lines are parallel. Number 8, KN, where's K? I can't even find K. I'm getting old, my vision's going. KN and JN. KN, I don't like that color at all. It's just not showing up very well. Let's use a little fluorescent green. All right, so KN and JN. Well, guys, you can see it right here. They even marked it for you with the right angle symbol. You've got a line going straight over and then a line going straight up. So those two lines are definitely perpendicular. Number 9, FK, here's FK right here, and HJ right here. Now listen, these two lines are never going to intersect. FK is going to keep going up and down forever and ever and ever, and this line here is going to keep coming out and out forever. Now, oh, Mr. Earhart, they intersected right there. Right there. No, no, no. Remember, guys, it's hard to draw this. Now, I know I have great drawing skills. Yes, I'm being sarcastic. Guys, this is going straight down to the floor, and this would be like coming off of your desk where you're sitting. It's just going to go straight across. They're not really intersecting, okay, at all. This is going straight up and down, and this line here is completely parallel to the ground. So these two lines would never intersect, and they're not in the same plane. They are not in the same plane. No way are they in the same plane. Look at FK. That's in the front plane right here. Look at JH. It's in the side plane right here. They are not in the same plane. So they're not going to intersect, and they're not in the same plane. These two lines are skew. And then we have JN right there and MN. Well, men and ladies, or men and ladies, these two lines are right angles. Right angles. Okay, they form a right angle. These two lines are perpendicular. They form a right angle. So these two lines are perpendicular. Okay, moving on to numbers 11 through 14. I'll read the directions out loud. Determine whether enough information is given to conclude that the statement is true. So let's start off with number 11. The measure of angle 11 equals 90. Now, students, don't go by what it looks like. Go by your postulates, theorem, corollaries, and definitions that you have learned, or hopefully have learned. All right, notice right here they tell us F is perpendicular to G. Now we have I forget if it's a theorem, postulate, or corollary that states perpendicular lines form 4 right angles. Perpendicular lines form 4 right angles. So with that in mind, that means I have a right angle here, I have a right angle here, I have a right angle here, and I have a right angle here. So do I know for sure that the measure of angle 11 equals 90? Yes, because we learned that perpendicular lines form 4 right angles. So yes, we definitely without a doubt can say, yes, we know that to be true. If I can get this eraser to work. There we go. All right, number 12. The measure of 9 plus the measure of 10 equals 90. Now look, students, we just said when there's two perpendicular lines, when two lines are perpendicular, they form 4 right angles. So I know this angle here is a right angle. That means if I take angle 9 here with 1 dot and angle 10 right here with 2 dots, if I add those two together, they have to add up to 90. They have to. So yes, I do know that for sure based on facts. Yes, definitely. Okay, continuing on. H is perpendicular to J. Now, be very careful. My first thought when I saw that was, no, how do you know that? But hold it, hold it, hold it. We have learned that whenever you have, I'm trying to get the wording just right. Whenever you have a straight line like this, it's going to equal 180. Okay, for example, if I have a straight line like this and a line coming off of it, I know that this angle here with 1 dot and this angle here with 2 dots is going to add up to 180. Okay, anytime you have a straight line, the whole straight angle is going to be 180 degrees, always. So now let me apply that up here for you. We know that this whole angle together is 180. Well, Mr. Earhart, just because they add up to 180 doesn't mean it's 90 and 90. Yes, it does, because notice how I have one mark here and one mark here. That means those two angles are congruent. That means they have to be the same. So the only way to get 180 when two angles are the same has to be 90 and 90. Think about it. There's no other two angles you could put there. 80 and 80, well, that's 160. 85 and 85, well, that's 170. The only two angles you can put here that are the same angles that add up to 180, and believe me, they have to add up to 180 because we have a straight line here. The only two angles are 90 and 90. So yes, we do know, because of these congruency symbols right here, because we know this angle here is congruent to this angle here, because we know that, then yes, we do know that H and J are perpendicular because we have 90-degree angles. And then number 14 says 9 is congruent to 10. Now we don't know that. Look, students, all that we know is that when you add 9 and 10 together, they're going to add up to 90. But we don't know. I mean, this angle right here, angle 10, maybe it's 46 degrees, and maybe 9 is 44 degrees. I mean, it looks like they're congruent, but you really don't know for sure. So you cannot say emphatically, yes, they're congruent. So no, you do not know that for sure. Okay, let's move on now to numbers 15 through 18. 15 through 18. Now, okay, all right, let me do a little bit of work here real quick. I really like my parallel lines. You guys know this by now, and I should have caught this earlier. I really like my parallel lines to run horizontally, left to right, not up and down. So I think what I'm going to do is this, and then this, and then this, and then that. And that didn't do anything, did it? All right. Yes, sir. I'm definitely teacher of the year here. Let's see, how can we do this? All right. Slide that down to there. And I guess we'll put that right back up there. All right, let's go ahead and see if we can't highlight this. This is really turning into a mess, and I apologize. All right, now let's see if we can't. Now that's weird. Usually I can turn this thing pretty well. One thing I am accomplishing is I'm wasting your time. There we go. I really do like this thing to be turned like this. That's just me. I'm sorry if I annoy you, but I think students see it a lot better. So 8 and 9 would be going across the bottom. 10 and 11 would be right here. This would be 12. This would be 13. This would be 14. And this would be, I said it was okay, Josh, it's fine. And this would be angle 15 right here. All right, here we go. Wow, that was a lot of work there. Angles 8 and 12. All right, here we go. Let's get our red. Here's 8. Here's 8. Here's 12. 8 and 12. Those are called corresponding angles. They're both on the left side of the transversal, and they're both below the parallel line. We call those corresponding angles. You've got to know those, guys. You have to. 9 and 14. Well, let's take a look here. Here's 9. Here's 14. Notice they're both on the exterior, so we know they're exterior angles. They're on opposite sides of the transversal, so we call those two angles alternate exterior angles. Alternate exterior angles. All right. And angles 10 and 12. Here's 10. Here's 12. Now, they're both on the interior. That means they're on the inside of the parallel lines. Or not parallel lines. Sorry, I got to quit saying parallel lines. They're both on the inside of the two lines that are being intersected by the transversal. So they're interior. And they're both on the same side of the transversal. So we call these two angles one of two things: consecutive interior angles or same side interior angles. Okay? Either way is fine. And then lastly, we're going to, there we go, and let's go like this. Lastly, we're going to look now at angles 11 and 12. So here's 11, here's 12. They're both on the inside of the two lines that are being intersected, so we call them interior angles. They're on opposite sides of the transversal, so we call those alternate interior angles. Alternate interior angles. Okay, moving on to numbers 19 through 21. The directions for 19 through 21 state, find the measure of the numbered angle. Find the measure of the numbered angle. So here we go. Well, I guess, now first of all, notice this, students, okay? Here comes Mr. Earhart again with his, now you see what the answer is. I like to turn this stuff around, so there we go. And all right. Now, look, notice these two lines are parallel. If these two lines were parallel, you really had no way of knowing whether or not these angles are congruent or supplementary or whatever. All right? So it's really important for you to understand, in order for us to know anything about these angles, you have to have parallel lines cut by a transversal. And we do have that. We have parallel lines cut by a transversal. Now, these two angles, you've got to learn this, they're called corresponding angles. And what we learned is when two parallel lines are cut by a transversal, corresponding angles are congruent. So angle 9 would also be 99 degrees. Okay? All right, number 20. And I guess we're just going to have to kind of look at these. I'm not going to turn all of these for you. So notice once again we have two parallel lines. This line here and this line here are parallel lines. So we have two parallel lines. And one of my boys is yelling, so I'm going to pause the video. Okay, sorry guys, I'm back. One of my sons came in the door there. So, all right, here we go. Now, we have two parallel lines right here and right here cut by a transversal. Now, when that happens, what do we call these two angles here? Well, these two angles are on the inside. They're on different sides of the transversal. We call these angles alternate interior angles. Alternate interior angles, okay? So what we've learned is when two parallel lines are cut by a transversal, alternate interior angles are congruent. So angle 10 would also be 63 degrees, okay? All right. Moving on to number 21. Now, I believe, let me look in the book here, this is 109 degrees right here. So I'm going to quickly write over this in green. This is 109 degrees. 109 degrees. Now, here's what we have. We have two parallel lines cut by a transversal, and these two angles here are called same side interior angles or consecutive interior angles. Now be careful, these are the two angles that are not necessarily congruent, they're supplementary. That means this angle here and this angle here have to add up to 180. So I'm going to take 180 and subtract out 109, and that will give me 71 degrees. So the measure of 11 is 71 degrees, okay? 71 degrees. All right, moving on to numbers 22 through 24. 22 through 24. Now, the directions say, find the value of x so that R and S are parallel. All right, now, if we want R and S to be parallel, like this, then we better first of all decide what these two angles are called. Well, this angle here and this angle here are called corresponding angles. And if we want these two lines to be parallel, then corresponding angles have to be congruent. So x equals 122 degrees. 122 degrees. All right, number 23. Now, we want this line here and this line here to be parallel. Now look, if we want those two lines to be parallel, then we better find out what the names of these angles are. And the names of these angles are called alternate exterior angles. Alternate exterior angles. And students, if these two lines are parallel, then alternate exterior angles have to be congruent. So we're talking that 4x equals 80, divide both sides by 4, and x would equal 20. Okay? X would equal 20. Now, number 24. Again, if we want this line here to be parallel to this line here, which we do, then we better first of all decide what's the names of these angles. Well, this angle right here and this angle here are called same side interior angles or consecutive interior angles, and they are not necessarily congruent, they are supplementary. So you take one angle, x minus 15, and you add to it the other angle, 55 degrees, and you set them equal to 180, because this is one angle right here, this is the other angle here, and I'm adding them together. And when I add them together, they better add up to 180. Now the first thing I see is I can simplify this left side. I have negative 15 and positive 55. That's going to give me a positive 40. A positive 40. Then next, I'm going to bring 40 over. And when I bring 40 over, I'm going to make it a negative 40. So I've got a negative 40 here. This is gone. So x equals 140. And that's the answer you should get for x, 140. Okay, moving on to numbers 25, 26, and 27. Use the given information. Using the given information, state the postulate or theorem that allows you to conclude that P is parallel to Q. Now, we want to prove that P is parallel to Q. Well, let's see what they've given to us. We know that P is parallel to R, and we know that Q is parallel to R. Now hold everything. I had a theorem I learned, and you can paraphrase on the test bar. You don't have to word it word perfect. You would just say two lines parallel to the same line are parallel. And that's what we have. P is parallel to R. Q is parallel to R. So P and Q are parallel to the same line. Thus, P and Q are parallel. So there we go. Moving on to number 26. All right. Now again, we're trying to prove that P is parallel to Q. Look what I have up here. I have P is perpendicular to S, and Q is perpendicular to S. Okay, now I've got a theorem. Here's what you would write. I've got a theorem that says if two lines are perpendicular to the same line, those two lines are parallel. So, if two lines are perpendicular to the same line, then those two lines are parallel. That's a theorem, or I think it's a theorem that we learned. So, P is perpendicular to S, Q is perpendicular to S, P and Q are both perpendicular to the same line S, so P is parallel to Q. 27. Now, by the way, we learned 6 ways to prove that lines are parallel. That'll be on your test, okay? Like we've gone over, we've talked about that. Will be on your test. You have to know those, okay? Well, here I can definitely state that P is parallel to Q, because look what I know. They tell me angle 1 is congruent to angle 2. Now, what is the names of angles 1 and 2? Well, if you don't know by now, you really better brush up on this tonight. They're called corresponding angles. And we know that when two lines are cut by a transversal, I'm going to go ahead and put it like this. Your reason would be corresponding angles are congruent. That's all you got to put. That's all I'm going to make you put. That's good enough for me. When two lines are intersected by a transversal in such a way that the corresponding angles are congruent, then the two lines are parallel. So we know P and Q are parallel because the corresponding angles are congruent. How do you know 1 and 2 are congruent, Mr. Earhart? Because they gave it to you right here. Look, right here. Angle 1 is congruent to angle 2. All right, 28. Decide whether or not, 28, 29, 30, decide whether the red figure is a translation of the blue figure. Now look, guys, we start with the blue and we work our way to the red. No, this is not a translation. I hope you're getting this. No, we studied this yesterday. Look, we didn't just slide P. We took P and we rotated it down and we came up with this. The only way you have a translation is when you slide the original object up or down or left or right. Now, yeah, we're good here. Here's our original object P. We went straight up, straight over, and there's P. We didn't flip it. We didn't twist it, turn it. Yes, this is an example of a translation. No, no. Here's what you started off with, and you had to rotate it down this way to come up with this over here. No, that is not a translation. Absolutely not. All right, now let's take a look at number 31. Now, number 31, if your book is open, you can see this here. Number 31 says, describe the translation using words. Now, first of all, I hope you remember you always start with the blue and work your way to the red. Okay? So here we go. Let me get a funky color here, a green color. Now, remember, you can't compare this point here with this point here. They're not corresponding points. I don't care which 2 points you choose as long as they're corresponding points. This point right here corresponds with this point right here. Now, let's go ahead and describe the translation. First of all, we went to the right. 1, 2, 3, 4, 5. So, right 5 units. And then we went down. We start here. Don't count where you started. We go down. 1, 2, 3. So we went down 3 units. Okay? So you describe the translation using words. But hold it. Now for number 32, they want you to describe the translation using coordinate notation. So remember how to do that? You start off with parentheses. You put an X, leave some space, put a comma, put a Y, leave some space, and close your parentheses. Now, X, of course, deals with your horizontal left-right movement because this is your X-axis right here. So, we know, first of all, we went from here to here. We already saw that we went over 5 units, okay? Now, did I go to the right or to the left? Well, we start with the blue and we go to the red. So, it would be 5 units to the right. So, X plus 5. Then from this point here, we went down 3 units, 1, 2, 3. So it's y minus 3. Now, if you would have went up, you would say y plus 3. Do you see now why it's so important to know what figure you start with, blue or red? If you don't know which figure to start with, then you don't know if you're going left or right, up or down. Because if you're starting with the right figure, then you went up and to the left. But if you're starting with the blue figure, then you went to the right and down. So you need to understand you start with the blue figure and work your way to the right figure. That's the end of the review sheet. I hope this has been a help to you. Please study well for your test. Call or email if you have any questions.